Okay, well, once again, welcome to the mock interview. Um, Session's going to be about an hour long. Usually, of these things, I'm not sure if you've done much interviewing before, but let me know if you have. But we're going to be doing. Usually, they open up with some like introductions and such. We're going to be skipping that today, so we'll go straight to the problem. We're going to target about 45 minutes or so of coding time. And then after that, we'll have about 10, 50 minutes or so of feedback, questions, etc., or anything you might want to bring up. How's that sound?
That's good.
Okay, cool. All right, so is Python your preferred language?
Yes.
Okay, great. Okay, so the first problem that we're gonna be tackling today is about multiply numbers. Okay, but it's not that simple. So I would like you to write me a function which takes in two strings. And by the way, you're free to take notes here, like in the editor. Yeah. So a function takes in two strings, but the strings are numbers, right? And they're going to be valid numbers. And you are to return a string, which is a result of multiplying the two numbers.
Okay, that makes sense.
Yeah, got it.
Yep.
Okay.
Hmm. Wait, so are there any restrictions on what the numbers can be? Like, is it an int?
Nope, no restrictions,
Okay.
but they're valid numbers.
Hmm. So would the return type be a string still? And then
Yes,
just okay.
that's right. Yeah.
Um. Hmm. So what do I want to do here? I guess. Do you have any hints for me?
Yeah, for sure. So one thing that we can kind of look at here is, the reason the numbers are given as strings in this case is because the numbers are too big to necessarily fit. Right now in Python, there's no restriction for the size of numbers, but in most languages there are. And for the sake of the problem, we're going to assume that we need to process this string a bit at a time.
Okay.
Okay. Um,
So is this saying like C++ style where it would be like 10, like showing that it's a long but that it's unsigned?
uh, no, so it would still be a number. So for example, let's
Okay.
assume that we could have like a number like like let's say like just say 40. I mean, obviously this is a small
40.
number, right? But it's a valid number. And so what we're not allowed to do is we're not allowed to go, like int string one. We were assuming that this operation would cause issues, right?
Oh, okay.
So let's say the language or the system cannot process the entire string at one time. It cannot encode it at one time. Okay. What I'm also going to tell you here, just to make things a bit simpler, is that the numbers, I'm going to restrict them now to be only integers. So we'll make that a restriction for now.
Okay, for now. So I'm going to make a result, and I guess my concern is the signs of the integers. So dealing with that first.
Okay.
So that's going to be string 0, or not, string 1, 0 equals this. I'm going to loop through string 1.
Okay.
And then
What's the multiplication algorithm you're thinking of right now?
I'm not sure.
Okay. We can start with just a regular, right? The regular multiplication, like, doing it on paper by hand,
Yeah.
right? If you have 40, multiplying by, let's do it easier. Let's do 12 and 23 or 34, right? In this case, you multiply the 4 times 12, right?
Yeah.
So it equals 4 times 12. And then you do 3 times 12, 12, right? But this is a tens place, so this is times 10. So in this case, it's like 30 times 12, right? So 10 times. We could do like 3 times 10. Does that make sense?
Yeah. So I guess we assume it's string 1 is 12 here. So if I want to string 2, and then we're gonna have a place. So this place starts with the multiplier of 1. So first, j or res 0. And then you want to plus equals j, which would be our 4 here, times we kind of just want the integer for string 1.
Yeah.
Yeah, so but you said we shouldn't do this.
Yeah, we're not allowed to cast a value to a built-in type in that case.
Okay, so first we'll build it. We'll say focus in 1, and then so it'll start off with the, or I guess I'll do in reverse as well.
Okay, so hold on a second. So what are we doing here?
I'm trying to build an int with the value of string 1 that string 1 represents. So then we can have this like 12 value here. So then I can go through string 2 and do this algorithm with the whatever this 12 is.
Okay, I see where you're coming from. The string 1 cannot fit in an integer, right? Like this is our restriction here in this case.
Oh, okay.
This is why it's passed in as a string. It's on the heap.
Okay. Um,
What we actually need to do here is we need to look at, so we had there was a start where you process the numbers digit by digit, right? So you have, in this case, you started with digit 4, that's your j. And then you look
yeah,
at, for digit 4, look at all the digits in string 1.
yeah.
And then you need to store that result somewhere. So your processor, I think, was on the right track, but you still need to think about where you're going to store that result of 4 times 12.
So we almost need like need to store the result for each digit. So I'd almost want like my n is length string 2, and then beginning with the 4. Times equals I times decimal place. I'll move this. So this, we want the 4 times 1 times 10. So we want to go through this in reverse instead, so that we can just increase by 10 for each one.
Okay.
So start it off at 1, because it'd be 4 times 2. And this won't be times equals. This will be plus, or plus equals. So our digit starts off as 4, and then I'm going to go through 12 in reverse, so starting at 2, and digit plus equals I, which would be 2 times decimal place, which is starts off at 1. Then after each iteration, I need to update my decimal place. Let's say it times equals 10. So I go to 1 to 10 to 100. So after I have that result, I need to store this. Wait, after I have this result, I'll have whatever my digit is. But this might run over. Well, I guess I'll just be adding them all up afterwards. So results of J equals digit. Wait, this, why is it mad at me?
You're using default dict as a type.
Oh. Nice.
Also because digit is a string. I mean, yeah.
Is an int, and
It's
it wants a oh, it's a string. Okay, so let me go through this again. Guess I don't need. And so I stored my results, and at the start I have my residual, or my return is 0. I'm looping through string 2 in reverse. So that would be the 34, starting with the 4. Yep. And then I'm going through 12 in reverse, so that's 4 times 2, digit plus equals. Oh. J. That makes sense. It was wrong. Oh. Okay, so we're gonna get the digit into I. So then we can add digit 2 times decimal place to the digit, and then move the decimal place up. So next one would be 1. Then we do 4 times 1. Okay, and then store that result for the integer, for the string of J 2 digit. Does that make sense? Not really. Or I guess I would just loop through again once more and then add all the results. But why don't I just do that? Wait, you mentioned we needed to store each of the results. Why did you mention that?
I mean, you don't need to store necessarily each of the results, but you do need to have the result somewhere. So
okay,
you decide how. I mean, you decide where you want to put it.
plus equals digit. Guess my only concern now is like negative integers. Let me make sure this makes sense first. So going through string 2 in reverse, start off each time with a decimal place of 1 because we start at the first digit, the 4 times 2. Then I convert the j, which would be like the 4, to an integer. That makes sense. And then I go through string 1 in reverse as well, so that we can start with the decimal place at 1. And then I convert that to an integer as well. And then, wait, why am I doing this? Digit plus equals digit 2. No. Times equals. Times 3, 4 times 2 times 1. I don't know what that was doing. So just say times equals. And then we move to the tens place, and then it would go 4 times 1, so it'd be, or 4 times 10, so it'd be 40 plus so 48. And then, yeah, okay. Why does not this get down here? But we want to return a string as well. Try running it.
Oh, we don't need to run that. That's not a big deal.
Oh,
Yeah, cool. Okay. So you mentioned negative numbers.
yeah.
What's the consideration there?
So if these are properly formatted, like the inputs are valid,
Yeah.
then we would want to consider wherever string 2 or string 1, wherever their first index is, we would want to make sure to check if those are the negative sign. And if they are, then how do I want to do this? So if this was negative, this was negative. I almost kind of want to just check these separately. And
Yeah,
then
you should
just
definitely
do
do
the
that. Yeah.
algorithm normally. Output sign. So like remove this. But I need to make sure that this only goes till 1. Or wait, no. I want to make sure I just ignore it in the loop. Because it's not guaranteed to be there. So this will be string 1 of 0 equals the symbol So I guess the best way is just to say they don't equal negative, and string 2 does not equal negative. Oh. Because we know if they both are, oh, I guess I have to do 2 checks. So call this sign. So either they're both not negative, or they both are. It's probably an easier way to do that. They're both not negative, or they both are. I guess the best way would be XOR for checking, but checking if they are negative and finding if only one of them are. But I think I'll leave that like that for now. And then at the end, let's do that at the end. Say res if or sign pause equals -1. Say one string that is negative. And then I want to make sure I don't mess up my my algorithm by including the negative signs. So if j equals negative sign, if I equals negative sign, this is the one I'm concerned about. Is continue the right keyword here?
Yep, that's right.
Okay. Okay. One input string is input number is negative. Then I'll say I think this is all I can think of for now.
Okay. So let's talk about the time and space complexity, please.
Okay, well we're doing a simple check. This is O1. And then we want to go through string 2 once, and then for each element of string 2 we go through string 1 once. So that would be, let's say string 1 is m, string 2 is n. So this would be O of n times m. Because for each element of n, we do this m times, and these are all O of 1.
Those are all O1? Okay. Can we go through those O1 operations, and can you explain to me why they're O1?
Um, Checking an element here.
Uh-huh.
So that's O of 1. And then
Yeah.
converting to an int from a char is O of 1.
Okay.
And then this is just elementary operations times
Okay.
and assigning a value. And then same thing here. And then finally, for each one is just an addition. So that's
Okay.
O of 1 as well.
Okay. And then the space, please.
Space complexity. I store the result in this this return, which starts off as an int and then is cast to a string. So I guess space complexity is whatever size res ends up being, which let's see, what would the maximum be here? If string 1 is I guess it would it be O n times m as well?
Okay. Okay. Can you explain the reason there?
Well, I guess the string that ends up storing, well, we store it in an int at first.
Okay.
So I guess it wouldn't be. It would be. We'd be storing this in. mm, that would. It wouldn't really be in terms of m or n. It'd be in terms of what they represent. But the final string, which would end up being storage as well, would have to be. Well, in the worst case, I guess, would be what would be the possible worst case for multiplying two strings integers? So I guess if it was like, let's say just for the case with 2 digits, 99 times 99, and then that's pretty much the same as just around 100 times 100 is then 1,000, which is about over double the input size. So maybe the final string that we have to store would be 2 times max n m.
Okay.
Yeah, that's all I can really think of.
Okay. No, I think that's a good place to start. So I'll note that down. We can come back to that later.
Okay.
Okay, cool. I want to move on to a second question. We're a bit low on time here, but I think
Yeah.
we might still be able to make a little progress on that one.
Okay.
So this problem is going to be called merge intervals. Have you heard of this one before?
No.
Okay, so I'll dictate that. So we can just start at the bottom, just underneath here.
Okay.
Okay, and for this problem, it's called merge intervals, and how it's going to work is you are to implement a function, and it takes in a list of intervals. Okay, and an
Okay.
interval is defined as a pair of numbers, a start and an end. Okay, it's going to be a smaller number and then a larger number. Okay, and they're all integers. And you have a list of these. Okay, and then you're going to return a list of interval, where the list you return is the smallest set of intervals that contains all of the intervals before. Okay, so here's an example. So I'm just going with you here.
Sorry.
No worries. So here's an example, right? We have 1,
Okay.
3, 2, 6. These combine to be 1, 6, right? Because these are overlapping.
Yeah.
Okay. And 8, 10, and 15, 18 do not overlap, right? These do not overlap.
Yeah.
So they don't combine. So the output is the smallest set of intervals that encompasses all the previous intervals, without any
Okay.
extras. Yeah.
So yeah, these two kind of just get combined. Okay.
Yeah, that's right.
Um.
I'll give you
Okay.
another restriction, which is that the intervals that are given will always be in ascending order. And ascending in this case is defined as the start of the interval. So this might be, for example, 18, but this is still
Okay.
ascending order because the first number is the smallest. Does that make sense?
Yeah. Okay. Merge intervals, and we're taking in intervals, which will be a pair of numbers. Let's just call this. Let's just call it this. And they're all integers. So for I in intervals, this will be going in ascending order. So we have our first interval, and the first value in each interval will be the lower one. So I'll say lower bound equals I dash 0, and upper bound equals I dash 1. And then I want to keep looking. I want to keep looking until the next interval has a value like that I can combine in to one
Yeah, I mean,
interval.
like you should always be looking greedily, right? Like in this
Yeah,
case,
because we're in ascending
we're
order.
in ascending order, so you should always be looking for your current for the start. You should be looking for the next one immediately.
Yeah. So um so I want to continuously.
I mean, let's think through the algorithm first, right? So,
Yeah.
so you start with the first element,
Yeah.
right? And then you're gonna we have that this must be in the output. I mean, like maybe not this n number, but this pair, like the starting number must be in the output, right? It just
Yeah.
must be. Okay, so this is in the output, and then we're gonna see if we can combine this value with the next.
Hmm.
And the way we can check that is if the first dot second value is greater than or equal to the second dot first value.
Yeah.
Okay. And if that is the
Okay.
case, then we want to combine them.
So I want to be checking. I want to be checking the rest of the pairs after I, or the rest of the intervals.
We only need to check the immediate pair after
Okay.
right? And the reason is because, let's say, I mean, there's only two cases. Like either is part we can either expand the interval or we can't, right? If we
Yeah.
can expand the interval, then 1, 6 becomes our new current interval, right?
Yeah.
If we can't expand the interval, then 2, 6 becomes our current interval. So regardless if we combine them or not, we will always know what our current interval is that we want to combine other intervals into.
Oh, okay. I think I get it now. Thanks. So what I want to check here is if the upper bound of our current one is greater than or equal to the next lower bound.
Yeah.
Or say this one is less than or equal to upper bound.
Mm-hmm.
And if that's true, then what do we need to do?
So let's do the same thing you had before.
So
A setup with the result. So let's just have a result,
yeah,
which is an array of pairs, right? And it will
yeah,
have a current, which is always going to be intervals, the first one, right? And so we can do what you've done here. I think this is a good start. I mean, obviously in this case we could start with the first one onwards, right? So the lower bound and the upper bound are just the current. So this is the same logic as you had, right? But now we have our current interval, right?
yeah. Okay.
And you're saying, okay, well, if it is part of the current interval, what should we do with the current interval?
Then we should update the current interval.
Okay. Yes.
And make its upper bound the next one's upper bound.
Yeah.
Current dash 1, that's the upper bound.
Yep.
Equals intervals I plus 1 1.
Yep.
Because that'll cover the whole thing, and that'll
Yes.
be in our results.
Yes. And what if in the else case?
So if they can't be combined, then we should add the current to our results and move the current to the next one, and then do the next check.
Yep.
So that would mean we would add current, and then current equals of I plus 1.
Okay.
And then it'll loop again, but be checking. Our current will now be 2, 6 in our example, and then we'll be checking against 8, 10. So I guess we don't need this lower bound here.
Okay, and then after the last iteration, you'll still have a current.
Oh yes. Okay. So let's think about that iteration. So we'll have 8, 10 as our thing. We see that doesn't overlap with the 15. So then the current, when during our last iteration, will be 15, 18. And then if that wasn't overlapping, then it still has to be a part of the results. So if it's not overlapping, where do I want to add this? Because if it is overlapping, it will have been, okay, if it was 10 to 18 instead, then it would have gone through this one, and we would have made the current that, but then it still would have been the last one. So either way, I want to add the current. So where's the append? So in this case, 8, 10 and 15, 18 don't overlap. So it'll be set to the current, or 15, 18 will be set to the current. And if they did overlap, then we would have just made the current bigger. But either way, way the loop would be done. So either way, I need to add the current. I think that makes sense to me.
Okay, sounds good. Time and space of this merge intervals.
Okay, well, we start with our first interval, and I think I can like assume these are all O1 operations like individually. Um, so we start with an interval, and for each interval, or we start with an interval, and then we're either going to merge it or add it to our result and move on. So read this one once, and then we move on, or we grow it, and then we read the next one. So I think let's say complexity is O of n, where n is our intervals. Because we need to read each one just once and then add it to our results, or it grows. And then space complexity. So this is considering our results. It's never going to be bigger than the amount of intervals that entered. It's never gonna grow. So, but in the worst case, it'll just be the same size as the input. So this would also be O of n, I'm pretty sure.
Cool. Any other comments about this? Otherwise, we'll go to the post game interview.
I don't think so about this one.
Okay, sounds good.
Yeah.
All right, so let's talk about it then. Let's talk about.
Yeah.
I mean, usually for these, like to start off by asking, like, how do you feel? What do you think went well? What do you think could be improved?
I think I did better on the merge intervals question.
Mm-hmm.
Just because it's more like other questions I've done.
Yeah.
But I think I just like really am bad with strings.
Okay.
And was also more nervous with this one. And
Yeah.
I should have asked more questions at the start to figure out what like we actually wanted for it.
Yeah.
But I felt with merge intervals I was able to understand what I needed to do more easily.
Yeah, I feel you.
Yeah,
Okay.
that's pretty much it.
Let's talk about it. So, the first one, I mean, the first problem is sort of like the main problem here, right?
Yeah.
Multiply number is a problem on Leetcode, though the version that I originally gave was quite a bit more difficult than the one on Leetcode. That one I think is a bit underwhelming.
Yeah.
After I made the restriction that they're only integers, then it became equivalent, I believe, to the one on Leetcode. I'm not sure the one on Leetcode allows for negative numbers, but either way, same difference. So, a couple kind of early comments about this thing, and if this applies a bit about both problems, is that it definitely helps to vocalize your thought process early on.
Yeah.
And if you don't say anything, it kind of says two things. One thing is that either like, oh, you know what's going on, you're gonna just crank this out, or it means that like you're really lost. You don't know what's going on. You don't know the next steps, and both of those don't set you up for success. So it sort of is in your best interest to kind of like start right from the beginning to kind of get right into it and start talking about things.
Yeah.
Now, one thing he did call out pretty early on was that the numbers could be negative, and I think that was a really good edge case detail you kind of noticed. Now, it seemed like you kind of forgot about that halfway through, so we had to remind you at the end there. So whenever you had those kind of thoughts about edge case or whatnot, you just gotta just write those down, and that might be something that you might want to just do in terms of figuring out a system for yourself. Like even when you don't do mock, you just do regular Leetcode or whatever it may be. Like you always follow your system, and so it becomes ingrained. It's part of how you approach problems altogether. So
Like when you say like talking to yourself or just
it
like
could be talking to
commenting.
yourself. I would recommend talking to yourself doesn't really work when you're nervous. I would
Yeah.
always recommend having a format you write down whenever you approach a problem. right? So
Oh,
for
okay.
example, so this is why Leetcode isn't really good because it doesn't let you practice this. But even
Yeah.
on Leetcode, you could still force yourself to do this, which is every time you're given a problem, the first thing you always do is you always write, like you said, take some notes about it, right? Take some notes about it. And then before you start coding, talk about the types. That's a really good thing to check, right? What are the input types? For example, the input types, right? Input string, output string. When you have these two things coming down, and this is not hard to identify, right? When you have this coming up, you just immediately ask yourself the edge cases. String edge cases, for example, are they all going to be? Now, this kind of question doesn't work well for this problem, but you can imagine more generally. For example, are they going to be ASCII characters? Are they going to be Unicode characters? How about uppercase, right? Numerical, right? Are they going to
Yeah.
be spaces, leading characters, right? I mean, this because I told they're all valid numbers just to make it a bit simpler, but in general, you can think about that, right? You think output string. Okay, what format do they want the string in? Are there other considerations there, right? Now, for other problems like like linked list or nodes or graphs or whatever, like this would give you some more insight, or even lists that would, like this kind of input output will give you a bit more insight. But whatever it takes, just form a system together and figure it out, right? So, for example, the string's supposed to be numbers, right? Numerical. If it's a numerical problem, the immediate things you ask, can it be? Is it what type of number is it? Can it be negative? Can it be complex, etc. Right? So
Yeah.
whenever these things come out, just automatically your mind has to come to these kind of problems, and then you can write it down, right? So numericals, right? So can be negative, right? Can be decimal. So these things you just write it down. That way you won't forget about it, right? Like these
Yeah.
are kind of systems that you got to develop so you don't make silly mistakes, because otherwise you're just wasting your time, right? You can't afford to take mistakes in that kind of situation. All right. So otherwise, I would say this is also about vocalization. Is talking about your short-term goals, right? The long-term goal we understand. What's a short-term goal, right? Like what are you trying to solve right now with the line of code you're writing, right?
Yeah.
If you're lost about certain things, that might not be this might not be easy to vocalize. But the thing is if you can't think of short-term stepping stone goals to get to where you want to be, then you also don't know what you're writing. Like you're also just wasting your time, right? So this might be, depending on the problem, the difficulty setting, it might be worth taking the time at the beginning, sit down, write it just in pseudocode or English in your comments, whatever. Just write down all the steps you're gonna take, and then that way when you're writing that, when you're implementing, you can say, hey, I'm doing step 3 right now. I'm gonna iterate through this second string backwards. I'm gonna iterate like this, etc. So that way it gives you a bit more clarity. It helps you structure your thoughts a bit better, because otherwise you're kind of willy nilly. You're kind of going back. You kind of you start at the beginning. Now you're at the end. Now you're back to the beginning. Now you're adding if there. Now you're adding if there. So there's a lot of stuff that's jumping back and forth, and it makes it confusing for you. Now here's the thing:
Yeah.
if you're actually correct, it's not a big deal because the interviewer knows the solution. They're just waiting for you to write it down, more or less, right? But if you're wrong, then the interviewer is also confused because they don't know what you're trying to do. They don't know if what you should be if what you're trying to do is what you should be doing, right? So that's another consideration, right? If you have low confidence in the solution, then you better take your time to write down like some of your ideas first.
Yeah.
Okay.
Totally.
Okay. So the other thing I'll talk about this problem. Honestly, I don't want to rag on this problem for too long, but this is not a great problem for Python, but it's actually a really good Python problem. Two reasons. First of all, the reason this problem is interesting is because you're not allowed to use integers. That's sort of the entire problem, right? Obviously, multiplication is not difficult. Everyone can do that. That's not the problem. The problem is not about multiplication. The problem is about how well do you understand the data of numbers. That is the actual problem, right? So when the problem given to you, that's something like, oh, you calculate the power of these two numbers, divide these two numbers. The problem is not about dividing. Like that's not the problem, okay? So you got to use a bit of your meta level understanding and say, okay, well, what are they really trying to test here? Because obviously, multiply two numbers is not a skill, right? So
Yeah.
the issue here is that you seem to miss, and this is why Python made it a difficult problem. Is in most languages, and I think you correctly identified this, and I think you said C++ or something, right? The numbers are all on the stack. When you're declaring numbers in a function, like in the body function, they're all on the stack. And there's a limit to how big numbers can be on the stack. Otherwise, you go to the heap, right? In Python, every object is on the heap. There are no objects on the stack. And so in Python, there's no restriction on, for example, how big numbers can be, right? However, that's not really the test here is not like can you make a number into a string or vice versa, right? The test is can you do that without converting them back and forth, right? Why is that important? That's important because your time complexity analysis is incorrect, and it is incorrect over here. This line is not a constant time, and the reason it's not constant time is because the size of this number is proportional to n. And only
Okay.
in Python can you get the situation where primitive multiplication is non-constant.
Why?
Because your decimal place, like how big can a number be? You tell me. You start at 1,
Um.
you multiply 10 every time, and you multiply by 10 a string 1 times, which is n. This number is
Yeah.
n to the power of, is 10 to the power of n.
I see.
So it's going to have n digits, right? It's going to have n digits. So you're multiplying a number that's 1 digit by n digits, which is in digits, which is in time.
Yeah.
So that's not a constant. So that's it. So you're actually going to be n squared n. So that's the problem.
Is there a way to do this in Python?
Uh,
That's not n squared n.
oh, absolutely. Yeah, I mean, the optimal solution would have been for time would have been m times n, and then well
Oh, okay.
technically it could be better than that, but for realistic interview performance, it's n times n, and space
Yeah.
should be n plus n, which is what you sort of had there. I mean, I'll talk about space right after, but
Okay.
the key that's kind of got you here is that you had some intuition, it seems, to build a solution up by digit, which is correct. But one thing you kind of didn't realize was you have like you end up having this digit variable around, which takes up like in space, right? And that's okay. It's okay to take up in space. That's not a problem. The problem is that you're going to be doing an in operation here again, and you don't benefit from that the first time around. What do I mean by that? Okay, like if you back up and think about it, our return type is a string, right? Like returning a string that represents the the answer, right?
Yeah.
But you can index strings, not directly, but think about strings as an array of characters or array of numbers instead, right?
Yeah.
Instead of doing result as a string, you could have done res as an array of digits,
Yeah. Oh.
and
Okay.
you will write your current string, which I mean again you wouldn't use a number here, use a string here. You would write this one by one into your result array, right? So it's a bit of pseudocode. This wouldn't be actually working, right? It's a bit of pseudocode.
Okay.
You would do something like res one at index I. That's not a real index, but just play with me here. Equals digit 2, and then and then your I would be incremented, right?
Oh. Okay.
So ideally, you would actually do something like this, and you would have index IDX. Right. This is how you would multiply it out, from like ideally. And of course, there's a carry. I won't do the carry here, but like this is the idea: is that you wouldn't
Yeah.
need to actually calculate the numerical multiplication. You would know implicitly where in the answer that number should rest.
Hmm.
So that is how you would avoid needing to do the multiplication in one go and then writing it all again in one go.
Yeah. I think that makes sense now.
You can go find the problem in Leetcode and do it there again. I won't explain the algorithm here. That's not important. One more thing I wanted to comment. I'm a little bit low on time. I'll spend a bit more time on this, but one thing I also want to comment is you're very close on the excuse me, very close on the space complexity. I'm not sure if you remember, but if you have 10 to the power of n times 10 to the power of m, that's m plus m, right? Does that
Yeah.
make sense? Like if you have 10, I'm using 10 as just a generic base, right? Times 10 to the power of m, this equals 10 to the power of m plus m, right? Hopefully that's familiar to you.
Yeah.
And so the answer here, so this is the problem essentially, right? So whatever your in is, like let's say you're in, so let's say like num1 is equals 99, like you said, right? So this would just be equals n equals 2. But because we can choose n to be whatever we want, so we say n equals 2 plus 1, and we can add any constant we want, right? We can add any constant we want because that's a constant operation on a linear function. And so this
Yeah.
is just, 10 to the power of n. So this is exactly the case I just said over here, right? And so your space is going to be O m plus m plus n, same difference, right? I would say most people would expect you to get this, especially if you went through the pain of actually writing the multiplication out. I would say it's expected that you could that you would be able to find this one. I mean, like your answer is not wrong, but it's not tight enough, so it's a bit
Yeah.
it's a bit like half marks. And then I'll spend a quick minute about merge intervals. This problem I think was pretty well done. Obviously, it did help quite a bit more, and you did struggle a little bit at the end trying to figure out how to operate with the current, the last interval. I think in general this might have been a bit of nervousness, or in general, I think what you could do to improve this, nervous or not, is working on like reading comprehension, like reading your source code, understanding what is going on, right? Oftentimes, especially if you're nervous, you're writing a lot of stuff based on patterns and memory, and you might not understand everything that's going on. So a good way to practice this actually is to go to Leetcode problems that you're like sort of familiar with, go to the solutions tab, and read through everybody's solution, right? And the goal there isn't really to necessarily understand why their solution is their solution, but your goal should just be to read it and understand why it works, and then just
Yeah.
move on. That's a really important skill that you need to practice. And honestly, reading other people's code is about as effective as reading your own. So for Leetcode, that's a really good thing to spend some time and practice on, because you really don't want to be caught. Don't want to be caught with a working solution. It's almost working. It's basically there, and you fumble on one of the last steps because that kind of removes a lot of confidence from the interviewer. Now they're
Yeah.
doubting if you're right because it's coincidence. Like you don't even know if you should add this or not. Like how do I know if you're doing this by coincidence, right? So like that's a really really important part to not fumble, especially when you're at the end just trying to run through it. So that could be something that you can just practice as well. Just reading code, understanding what's going on.
Totally.
Okay. Any questions from your side? I think you cut out there.
Yeah. I guess like what would you say like is the most effective way to practice like these type of questions? Just to be ready, like I get like the writing down everything as you do them. Um, but just to be like ready for interviews more so.
There's a lot of different ways to practice that. I mean, I would say, today's performance, it's hard to just judge based on one performance. I would say in general, there's kind of two things to tackle simultaneously, right? Like one side is just technical skill. So that
Yeah.
in this context, what that means is just going through somewhere and knocking out a problem quickly, like being able to just get to the answer, figure out in your head very quickly what it is, and then having the skill to execute and implement it. That's like a technical skill, right? So that's something you could always work on. The best way to
Hmm.
work on that, I'd say, is going through something like Neat Code 150, just one of those lists. Practice. Slow. Don't practice too quickly. Slow down. Actually understand the problems, but get through the topics there, right? And the secondly, what I said earlier today was about the actual interview style, right? Like, know what notes you need to take. Know what edge cases always trip you up, right? Know how to talk while coding. Know how to vocalize your short-term goals, long-term goals. Where are you right now? What step are you doing? That kind of thing. Strategy kind of idea, right?
Yeah.
In
I
terms of
feel like
that, you could go ahead.
the short term goal and long term goal is like a really good thing to point out. I feel like that would help a lot.
Yes, that's something which whether or not you realize it or not, that's what everyone's doing, right? So
Yeah.
if you can vocalize it, that helps the interviewer understand what you're trying to accomplish, which is really important.
Totally.
It's really important if you don't get the correct answer. Like if you get the correct answer, no one really cares. Like okay, cool. If you get the wrong answer, then that's all that matters because now I have nothing to judge you on. Like it's just wrong.
Yeah.
Like what can I say? So otherwise, practicing that, practice it by yourself. Just talk to yourself, right? See what's going on. You can get some friends to do mock interviews with. The key note is that your friends don't need to be competent. They just need to know how to ask you in English. That's it. And then otherwise, I would say it's a balance between the two. It's a balance between getting good technical skill and getting good interview strategy. So don't just focus on one. You have to keep them roughly balanced. That's all.
Thank you so much.
You're very welcome. All right, take care.
You too.